In this example, we will use z-scores to compare multiple normal distributions. Todd is a high school student who just took the SAT. The following are his SAT scores for math and critical reading, along with the overall mean and standard deviation for the students who took the test in the same year. Let's first draw the distributions for critical reading and math SAT scores. So for the critical reading score, we know that this is normally distributed with a mean of 495 and a standard deviation of sigma. So if we were to go one standard deviation up from 495, that would be 611. Two standard deviations up would be 727, and three standard deviations up from the mean would be 843. Now, remember that this normal distribution is just most likely approximate, so the fact that we get a value of 843 and that's not actually a possible SAT score is okay. All right, so down from 495, that's going to be 379. Two standard deviations down will be 263, and three standard deviations away from the mean will be 147. All right, and this is the critical reading scores. Now for the math scores, the average is equal to 511. The standard deviation is then equal to 120. So one standard deviation up from the mean will be 631, two up will be 751, and three up from the mean will again be not in a possible value, but it'll be 871. All right. One down from the mean will be 391, two standard deviations down from the mean will be 271, and three standard deviations down from the mean will be 151. All right, so now we have our critical reading and our math scores. Let's mark where Todd's score is. And so Todd is, for the critical reading, 526, so that's right about here. So if we eyeball it, that's 526. And for his math score, he's at 535. So that's right about here, 535. And if we're just eyeballing these two distributions, it looks like he scored relatively the same on both of the portions of the SAT. However, we can actually calculate exactly how many standard deviations away his score is from the mean by calculating z-scores. So if we calculate the z-score, what we're doing is we're transforming each normal distribution with different means and different standard deviations to the standard normal distribution, which is denoted by z. So his z-score for the critical reading would be 526 minus the mean of 495 divided by the standard deviation. So again, a z-score is just equal to x minus mu over sigma, and that's what we've done here. And the z-score for the math score is then 535 minus its mean of 511 divided by the standard deviation of 120. So the z-score for critical reading is equal to 0.27, and the z-score for math is 0.20. So what this means is that if we were to draw this on a standard normal distribution that has a mean of 0 and standard deviation of 1, he scored 0.27 standard deviations away up when we're talking about his critical reading score, and he scored 0.2 standard deviations away from the mean when we're talking about his math score. So it looks like he scored better in reading than in math, all right, because he has a higher z-score for critical reading rather than the math section of the SAT. All right, this is how we can use z-scores to basically transform any normal distribution into the same standard format.